Alright, so today in Advanced Algebra Trig, we covered section 3.1 and 3.3. The two big important ideas from 3.1 are reviewing of the distance formula and the midpoint formula. So the distance formula, we set it up, gives you a distance, of course. So we had 2 points on the plane. We gave point A and we gave point B. And A, we gave generic points x1 and y1, and B, x2 and y2. Figure out that the distance of this line here is x2 minus x1. The distance of our y coordinates would be y2 minus y1, and we came up with the distance formula right down here. Super important. It's just the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So we did the distance formula, then we also developed the midpoint formula, which is a location. Okay, because I don't want to get the two confused, right? So the midpoint formula is somewhere in between, or is actually the midpoint of A and B anywhere on the coordinate plane. So what we figured out was that basically the midpoint is just the average of the x's and y's. So we add up the x's, divide by 2, add up the y's, divide by 2, and that gives you an x, y coordinate location. Okay, we'll practice with this in class, but that's the formula that we came up with. Okay, in section 3.3, we first start out with talking about the slope of a line, and everyone seemed to remember lots of things about it. We said that we call it m, all right? We started with m, and we said that it's the rise over the run, and then some physics people say it's delta y over delta x. And then we came up with the formula for finding the slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So when we describe the slope, it can be one of these four choices. It can be positive, negative, or 0, or it could be undefined. So that's how we're going to describe slopes: positive, negative, 0, or undefined. Then we talked about the three different types of ways you can describe a line. You can use point slope form, where they give you a point and a slope. So the point in this case would be the y's, y1 and x1. And the slope would be the m, so I colored that in blue for you so that you can see. So then I gave an example. Okay, if we have the point 1, 2, and the slope is 4, can you put it into slope intercept form? And everyone could easily do it quickly. We say, okay, this is the y sub 2 or 1. Excuse me. This is the x sub 1. So we plug them in. So y minus 2 equals 4 times x minus 1, and that would be the answer for that one. And we noticed that the signs changed to fit the formula up top here. So we talked about that. Okay, then there was slope-intercept form, and I misspelled it, so I made an R out of it. Slope-intercept form is the one that everybody seems to remember. It's y equals mx plus b, where m is the slope and b is the y-intercept. So then I asked everybody, okay, take the last equation that we did that was in point slope form, and turn it into slope-intercept form. So the way we do that is, okay, we have y minus 2 equals 4 times x minus 1. So y minus 2 equals 4x minus 4. Add the 2 over, and you get y equals 4x minus 2. So we came up with the slope is still the 4, and the y-intercept was negative 2. And then we graphed that using our calculators, and we saw that the slope was indeed 4, and the y-intercept was negative 2. Then we went on to standard form, right? Standard form is ax plus by equals plus c equals 0. And I gave an example of, okay, well, 2x plus 3y minus 6 equals 0. It doesn't look anything like these other two forms. And we said, what is this form good for, right? So we came up with it that this form is good for making quick sketches. So, and the way that you do that is you find the x and the y intercepts for each of those things. And the way you do that, to find the x-intercept, you set the y equal to 0. So we're going to say 2x plus 3 times 0 minus 6 equals 0. So plugging in a 0 right there for the y. So that means that 2x equals 6, so x must be 3. And don't forget that you have a point, right? 3 comma 0 is now a point that's on that graph. Same thing for the y-intercept, set x equal to 0. So we have 2 times 0 plus 3y minus 6 equals 0. Therefore, doing some algebra, y equals 2. So you can see that 0, 2 is a point that is on the graph right there. So if I was going to create a graph, okay, I could easily go to 0, 3, 1, 2, 3, put a dot, and, oh, sorry, it's totally wrong. Let's back that up. Let's try that again. 3, 0, 1, 2, 3, and then 0, 2, 1, 2. Draw a line that connects them. So therefore, this line is the graph of that equation right there. And that's what we did.